The year is 1943. The sky above the European continent is not merely a battlefield, it is a killing zone, a freezing, oxygen-thin realm where thousands of young men are dying in aluminum tubes. The American strategy to win the war, the doctrine that has consumed billions of dollars in years of planning, relies entirely on the concept of heavy, daylight precision bombing. The theory is that if you can see the target, you can destroy the industrial heart of the enemy. But by the autumn of 1943, that strategy is failing, bleeding out in the cold skies over Germany because of one simple, brutal fact: range. The B-17 Flying Fortress and the B-24 Liberator are the heavy hammers of the 8th Air Force. They are bristling with defensive armament, designed to fly in tight combat boxes where their overlapping fields of fire create a porcupine of .50 caliber machine guns. But their hammer is defenseless once they pass the theoretical line of safety. The American fighter escorts, the sturdy, tubby P-47 Thunderbolts and the twin-boom P-38 Lightnings, are formidable machines, but they are short-legged. They burn fuel at a ferocious rate. Somewhere near the German border, usually around Aachen or Emden, the escort pilots have to waggle their wings, turn 180 degrees, and head back to England, leaving the bombers to fly on alone into the heart of the Reich. This point of departure, known bitterly by the bomber crews as the coffin corner, was where the slaughter began. The German Luftwaffe, flying the agile Messerschmitt Bf-109 and the heavily armed Focke-Wulf FW-190, learned to wait for this precise moment. They would amass just beyond the range of the American fighters, circling like sharks waiting for the lifeguard to leave the water. Once the P-47s turned back, the German interceptors would queue up, sometimes 3 or 4 abreast, and slash through the bomber formations with 20mm cannons and heavy machine guns. The carnage was industrial in scale. On October 14, 1943, the crisis reached its nadir. The 8th Air Force launched the 2nd Schweinfurt raid, a massive armada targeting the ball bearing factories critical to the German war machine. It was meant to be a knockout blow. Instead, it was a massacre. Of the 291 unescorted bombers that reached the target area, 60 were shot down over enemy territory. Another 138 were damaged so severely they would never fly again or crashed upon landing. The casualty rate approached 25%. In a single afternoon, the 8th Air Force lost more men than the Marines lost taking Tarawa. The mission was a strategic failure that forced the Allied commanders to briefly halt deep penetration bombing. The message from the traumatized bomber crews was unified and desperate. We cannot do this alone. We need deep escort. We need a fighter that can fly to Berlin and back, or the bombing campaign is dead. The answer to their prayers was already flying, but in a cruel twist of irony, it was being openly dismissed by both Allied commanders and German engineers as a technical mediocrity. It was a plane that had been relegated to low-level reconnaissance and ground attack duties. It was the P-51 Mustang. The story of the P-51 is not one of meticulous long-term military planning. It is a story of desperation, improvisation, technical brilliance, and a unique industrial synergy that only the Allied powers could muster. It is the story of how a failed airplane became the weapon that broke the Luftwaffe.
It begins in April 1940, not in the Pentagon, but in a smoke-filled room in London. The British Purchasing Commission, terrified by the looming threat of the Luftwaffe and desperate for any fighter plane they could get their hands on, approached North American Aviation, Inc. in Inglewood, California. At the time, NAA was not a premier fighter house. They were known for building trainers like the T-6 Texan and medium bombers. The British, having exhausted other options, asked them to build Curtiss P-40 Warhawks under license. The P-40 was a sturdy, decent aircraft, but it was 1930s technology fighting a 1940s war. NAA's President James H. Dutch Kindleberger was a hard-charging industrialist who hated the idea of building someone else's inferior design. He looked at the British specifications and offered a brazen counter-proposal. "We can build you a better fighter than the P-40, he told them, "and we can do it in less time than it would take us to tool up to build the P-40. It was an audacious gamble. He was promising a plane that didn't exist, to be built by a team that had never designed a high-performance fighter. The British, with their backs to the wall, accepted the offer, but they attached a crushing stipulation. NAA had 120 days to roll the prototype out of the hangar. Kindleberger's team, led by two brilliant engineers, the German-born Edgar Schmude and the American Ray Rice, went to work. They lived in the drafting room, they slept on desks, and in 102 days, beating the deadline by nearly 3 weeks, they rolled out the prototype, the NA-73X. The aircraft was sleek, angular, and looked fast even when sitting still. But its beauty hid a revolutionary secret. The Mustang was the first aircraft ever designed to utilize a radical new aerodynamic concept, the laminar flow wing. To understand why this mattered, you have to understand drag. In traditional wing designs of the era, the air flowing over the wing would become turbulent very quickly, creating a chaotic layer of burble just inches above the skin. This turbulence acted like an invisible anchor, dragging on the plane and forcing the engine to work harder. The laminar flow wing was different. Its point of maximum thickness was pushed much further back, and its curve was mathematically calculated to keep the air flowing smoothly, in laminar layers, over a much larger percentage of the wing's surface. This was the first miracle of the P-51, aerodynamic genius. The wing drastically reduced drag at high speeds, meaning the plane required less fuel to fly at the same speed as its competitors. But the engineers at North American didn't stop there. They incorporated another piece of aerodynamic wizardry known as the Meredith effect. They placed the radiator scoop, the large open mouth under the belly of the plane, in a specific position to take advantage of the heated air exiting the cooling system. As the air passed through the hot radiator, it expanded and was jetted out the back of the scoop, actually creating a small amount of jet thrust. The P-51 was a propeller plane that got a little push from its own cooling system. But despite this aerodynamic brilliance, the Mustang was born with a heart defect. It was equipped with the American-made Allison V1710 engine. The Allison was a rugged, reliable engine excellent for low-altitude work, but it relied on a single-stage supercharger. A supercharger is essentially an air compressor that stuffs more oxygen into the engine as the plane climbs into thinner air. The Allison's simple supercharger worked fine at 10,000 feet, but above 15,000 feet, it choked. It simply couldn't compress the thin air enough to keep the engine fed. Above that altitude, the engine's power dropped off a cliff.
When the early Allison-powered Mustangs, designated P-51A, arrived in England in 1942, the Germans encountered them and immediately dismissed them. They saw a plane that was fast on the deck but helpless in the vertical. They relegated it to the status of a nuisance, a good ground attacker perhaps, but certainly not a threat to the Luftwaffe's high-altitude interceptors. The German engineers correctly assessed that the Mustang, in its initial configuration, could not fly and fight effectively where the B-17s flew, above 25,000 feet. This technical judgment, while accurate for the Allison engine, would prove to be the most catastrophic oversight of the air war. They assumed the Mustang's limitations were permanent. The alchemy that transformed the P-51 from a ground attack obscurity into the angel of death for the Luftwaffe took place not in a Pentagon boardroom, but on a windy airfield in England. In late 1942, a Rolls-Royce test pilot named Ronald Harker was invited to fly one of the imported Allison-powered Mustangs. Harker was a connoisseur of aircraft, and after a 30-minute flight, he landed the plane in a state of agitation. He was astounded by the airframe. It was slippery, responsive, and dive-tested like a brick. But he was baffled by the engine. he realized immediately that the airframe was a thoroughbred horse pulling a plow. Harker supposedly turned to the engineers and said this aeroplane would be a world beater if you put a Merlin in it. He knew that the solution was sitting right there in the Rolls-Royce inventory. The Merlin engine, specifically the new 60 series, was a masterpiece of high-altitude engineering. Unlike the Allison, it utilized a two-speed, two-stage supercharger. This was a complex mechanical watch of a device that used two fans to compress the air in stages, keeping the engine fed with sea-level pressure even in the thin, freezing air of the stratosphere. The exchange was proposed. It was a logistical nightmare. Fitting a British engine into an American airframe required redesigning engine mounts, cooling lines, and cowlings. But Rolls-Royce engineers, working with a speed born of war, mated the Merlin 65 to the Mustang airframe. The result was the Mustang X, the prototype of the P-51B. The transformation was instantaneous and shocking. The Merlin engine gave the laminar flow wing the power it had been begging for. The top speed jumped from 390 miles per hour to over 440 miles per hour. The service ceiling, the maximum height the plane could fly, rocketed from 20,000 feet to over 40,000 feet. Suddenly, the Mustang wasn't just matching the German Bf-109s and FW-190s. It was outrunning, outclimbing, and outdiving them. But a prototype is not an air force. To win the war, the Allies needed thousands of these engines. The British factories were already maxed out building Merlins for their own Spitfires and Lancasters. They couldn't supply the Americans.
This led to one of the greatest acts of industrial technology transfer in history. The blueprints for the Rolls-Royce Merlin were flown to Detroit to the Packard Motor Car Company. Packard was synonymous with luxury automobiles, known for their V12 engines and obsession with quality. But this was a different beast. The British engineers built engines like watchmakers. Every part was hand-filed to fit. If a bolt didn't fit, they shaved it down. American mass production demanded absolute interchangeability. A bolt made in January had to fit a hole drilled in June. Packard engineers had to redraw thousands of blueprints, converting British Whitworth thread standards to American SAE standards. They had to redesign tolerances for mass production. It was a monumental task, but Packard delivered. Soon, the Packard V1650 Merlin was rolling off assembly lines in Detroit by the thousands, indistinguishable in performance from its British cousin, but built with the relentless speed of American industry. With the engine problem solved, the P-51B was a hot rod. But it still had one problem: range. It could fly further than a Spitfire, but it still couldn't reach Berlin on internal fuel alone. The engineers at North American Aviation tackled this with two distinct solutions. First, they did something dangerous. They installed a large 85-gallon fuel tank right behind the pilot's seat inside the fuselage. This gave the plane tremendous legs, but it terrified the test pilots. The weight of the fuel moved the plane's center of gravity backward, making the aircraft unstable and twitchy. If the pilot pulled back too hard on the stick with a full fuselage tank, the plane could snap into an uncontrollable spin. The operating procedure was grimly simple. Fly gently until you burn off the fuselage tank, then you can fight. But even that wasn't enough for the deep penetration missions. The final, decisive step that allowed the Mustang to fly 1,600 miles to Berlin and back was not a high-tech innovation. It was a logistical one. It was the invention and mass production of the external drop tank. A drop tank is a simple concept, an aerodynamic pod carrying extra fuel that hangs under the wing. When the fuel is gone, or if a German fighter appears, the pilot hits a switch, the clamps release, and the tanks fall away, instantly restoring the plane to its clean, fighting configuration. The P-51 was designed to carry two of these tanks, but there was a shortage of aluminum. The Allies couldn't afford to throw away hundreds of aluminum tanks on every mission.
So, American industry pivoted to materials that the Germans would have laughed at. They began mass-producing drop tanks out of papier-mâché and laminated plywood.
These tanks were glued together, impregnated with plastic to make them fuel-tight, and painted silver. They were cheap, disposable, and could be manufactured by furniture factories and paper mills. Yet these 75-gallon and 110-gallon paper tanks were the logistical key that unlocked the entire strategic bombing campaign. With 208-gallon paper tanks, a P-51 Mustang could carry enough fuel to fly from England to Berlin, fight for 20 minutes, and fly home. When these long-range Mustangs began appearing in late 1943 and early 1944, the Luftwaffe was caught completely off guard. They simply didn't believe it was possible. On March 6, 1944, the Allies launched a mission that signaled the end of the Luftwaffe. It was the first massed daylight raid on Berlin. 730 bombers were escorted by a staggering force of 800 fighters. The German high command watched their radar screens in the raid tracking centers. They saw the bomber stream approaching. They watched the blips of the American fighters. They waited for the moment, the usual moment near the border where the fighters would turn back. But the blips didn't turn back. They kept coming. They crossed the Rhine. They crossed the Weser. They kept coming all the way to the capital. The sight of silver Mustangs glinting in the sun over Berlin was a profound psychological shock to the German populace and the pilots. Hermann Göring, the head of the Luftwaffe, had famously boasted that no enemy plane would ever fly over the Reich territory. Now, single-engine fighters were strafing the streets of his capital. But the arrival of the Mustang brought more than just presence. It brought a change in doctrine. Until early 1944, American fighter escorts were shackled to the bombers. They were ordered to stay close, to fly in tight formation with the big friends, and only attack German fighters that directly threatened the bombers. It was a defensive, reactive strategy that gave the initiative to the Germans.
When General Jimmy Doolittle took command of the 8th Air Force, he looked at the Mustang and realized he was wasting it. He walked into the fighter pilot briefing room and pointed to a sign on the wall that said, "The first duty of the 8th Air Force fighters is to bring the bombers back alive." Doolittle ordered the sign taken down. He replaced it with a new order. "The first duty of the 8th Air Force fighters is to destroy German fighters." He unleashed the Mustangs. They were no longer tethered to the bombers. They were authorized to range out ahead of the formations, to roam freely, to hunt. They began to employ wolf-pack tactics of their own. They would scour the sky for German fighters forming up for an attack and dive on them before they could even get near the bombers. Even more devastatingly, on the return trip, when the bombers were safe, the Mustangs were ordered to drop down to treetop level and strafe German airfields. They destroyed the Luftwaffe on the ground, blowing up parked planes, fuel trucks, and hangars. The result was a war of attrition that Germany could not win. The P-51, with its superior speed and maneuverability at high altitude, was a better plane than the Bf-109 and FW-190 at the altitudes where the battles were fought. The German pilots, many of them veterans with years of experience, were being bled white. They were fighting for their lives from takeoff to landing. They couldn't train new pilots fast enough to replace the losses. The numbers were devastating. In the first 5 months of 1944, the crucial period leading up to D-Day, the USAAF claimed over 3,000 enemy aircraft destroyed. The Luftwaffe was effectively broken as a fighting force capable of stopping the invasion. They had planes, but they had no fuel, and critically, they had no experienced pilots left to fly them. The Mustangs had killed them. The German failure to produce a long-range bomber escort of their own during the Battle of Britain had cost them that campaign. Now their failure to anticipate the American solution to the same problem cost them the war. They had prioritized the elegant complexity of wonder weapons like the Messerschmitt 262 jet fighter. The Messerschmitt 262 was a technological marvel, 100 miles per hour faster than the Mustang, but it was temperamental. Its engines required overhaul every 10 hours and it consumed scarce fuel at a prodigious rate. It was too little, too late, and too complex. The Americans, by contrast, had focused on the simple, mass-produced practicality of the P-51. It was a plane that could be churned out in massive numbers by North American Aviation's factories in California and Texas. It used a piston engine that mechanics understood. It used fuel that was plentiful, and it was flown by pilots who had been trained in safety in the skies over Texas and Arizona, far from the enemy guns. The final verdict on the P-51's simplicity and ubiquity was delivered by the leader of the enemy Air Force himself. After the war, during his interrogation by Allied officers, Reichsmarshal Hermann Göring was asked when he knew the war was effectively over. He didn't mention the Battle of Stalingrad. He didn't mention the Normandy invasion. He made a famous remark that encapsulated the failure of the German air defense. "When I saw the Mustangs over Berlin," Göring said, "I knew the war was lost." He realized then that the sanctuary of the German heartland was gone. He realized that the Allies had solved the physics of the air war.
By the end of the conflict, the United States had produced nearly 15,000 P-51 Mustangs. It was a testament to the power of industrial synthesis, proving that the most direct, mass-producible solution, even when it starts as a rejected prototype with a bad engine, can be transformed by a single good idea. The marriage of the American airframe with the British engine, amplified by the logistical triumph of the disposable drop tank, created a weapon that changed history. The flight to Berlin and back, a grueling 1,600-mile round trip over hostile territory, was not just a feat of pilot endurance. It was the industrial and strategic victory that secured Allied air superiority, paved the way for D-Day, and ultimately brought the 1,000-year Reich to its knees in rubble. The P-51 didn't just escort the bombers, it cleared the sky. If you enjoyed this story of industrial might and aerial supremacy, please hit that like button. In the comments, tell us, do you think the Me-262 could have changed the war if it had been produced earlier, or would the sheer numbers of Mustangs have overwhelmed it anyway? Subscribe so you don't miss our next deep dive into the truckers who saved the Allied advance, the Red Ball Express. This is the World War II Archives.